Springs today.
There are many different types of springs. The one people are most familiar with is the helical compression spring, as seen here. When the spring is unloaded, we say that this is its free length form. When the spring is completely closed with no spacing in between the coils, we call this the solid length form. Every coil that is not touching the end or in contact with another spring is called an active coil. The free length, solid length, and number of active coils coupled with the known material of the spring provide a multitude of information in the design of these components.
This spring here is composed of two separate conical springs with their smaller springs touching. Conical springs allow for the nesting of smaller coils inside bigger coils. There is also a cone angle, as seen here.
When people think of springs, they think of coil springs. In reality, a multitude of objects can be used as a spring as long as the material remains within its elastic limit. For example, this ruler right here can be used as a spring. This type of spring is known as a cantilever beam spring.
Yes.
So if anything can be modeled as a spring, how do you explain the spring constant?
As you can see here, there are two main components, the physical component using the Young's modulus and the geometric component using the moment of inertia. Using these two main components, we can get the value of K for any spring. In this example, as Matthew showed, it was the cantilever beam.
That's not the spring I'm looking for. The spring I'm looking for has way more applications, like in this coffee cup, or in this trash can, in this light switch, maybe even this door handle.
Or the compression spring with this Nerf gun.